First of all, I would like to thank you, the students, for participating for this session, which is going on recent changes for the BLA Digital Business Strategy. Let me introduce our key person today, key speaker today, Dr. Indra Mahakalanda. He is from the University of Moratuwa. So he will explain you what are the changes which have been done for the Digital Business Strategy BL8 examination, and how it is tested at BL8 on-demand examinations. Over to you, sir.
Thank you, Ms. Augusta. So the changes to the BL8 textbook, we have done mainly changes to chapter 1 and chapter 2. So what we have done to, so I'm going to start the session, today's session, with chapter 2. Then next week, I'm going to focus chapter 1. So chapter 2 mainly focuses on data analytics, so industry 4.0. So those are the big data. So that's what we intend to cover in chapter 2. So today session that I'm going to take will go a little bit beyond the contents of chapter 2, but that is mainly for you to understand the areas that we discuss in the chapter with more practical aspect, right? So I'm going to give you some, show you, demonstrate some practical applications of what we have discussed in chapter 2. Okay. So if you have any question, you can, there are two ways. Either you can stop me and ask directly, or the other method is you can type your question and put it to the chat box. There's a chat, if you can see in the, I don't know whether the chat is enabled for you. I believe chat is enabled. So either you can type your question in the chat, right? So then I can read and answer. Or even after we finish the session, I will give about 5 to 10 minutes, depending on the number of questions we get. So there will be a question Q&A, question and answer session. Or else, if you get any question, if there's a question for you, maybe later even you can query with the Chartered Institute, and they will pass it on to me, right? So with that, I will start the session. So what we are trying to do today is to give you an introduction to the area of data analytics. So what I'm going to cover, these are the things that we have covered in the text, chapter 2. So I'm going to introduce Industry 4.0, data analytics and big data. Just give a kind of surface knowledge on this. And but I'm going to, in detail, I'm going to discuss what is data analytics. And I'm going to demonstrate some descriptive analytics as well as predictive analytics little bit, and discuss what it means by machine learning, which is a part of predictive analytics, and how they use it in the finance world, right? So this is the agenda for the day, for the session outcomes. So let me start with this information revolution or industry 4.0. So this whole gamut of big data, artificial intelligence, digital twin, then there are so many buzzwords have come to this world during last 5 to 10 years, right? So mainly because the concept of industry 4.0. So this how they have introduce this Industry 4.0. Now, if you know the industrial revolutions that had happened over the years, so they categorize those industrial revolutions into four revolutions. So, Industry 1.0 is the first industrial revolution that took place somewhere around 1780s to um, at least first part of 18th century, right? So mainly during the first industrial revolution, the world experienced the mechanization, steam engines, right? So that is what we call by Industry 1.0. Then somewhere around 1850, 1860, 1870, up to 1910, 1920, um, we uh, we can see how the manufacturing changed, right? Instead of individual small scale manufacturing, um, the the world started doing mass scale production with very large assembly lines. For example, Ford Motors in US, right? So that type of very large plants where you have assembly lines, and per day you see maybe 100, 200, or even more cars being manufactured, right? So that's what we call Industry 2.0, where we see large scale manufacturing with uh, very large factories. Then we move on to the world has moved to Industry 3.0. That is in 1960s, 70s, late 80s, likewise. So there we see mainly the automation taking place, where we see robots coming into the picture instead of human labor in certain particular areas, specifically somewhat they, so let's say, uh, if it is dangerous type of operations, we see the involvements of robots, robot arms, not entire, may not be the entire robot, but at least robot arms, right? So this was possible due to the progress of electronic industry, right? So 1960s, the there was this innovation of integrated circuits we call ICs, right? Chips. So with these ICs or chips, the um, world or the man, human, able to manufacture computers, right? And various other electronic devices. With that, this automation was possible. Right today, after 1990s or even in the millennium, we experience Industry 4.0, right? So with Industry 4.0, what now? Now, if you take Industry 3.0, the man has to give some instructions to the machines. Now, let's say if I were to operate a computer, I I had to give some instructions to the computer in the form of some machine language or any other. It can be high level language, and then I had to ask the computer to do some or perform something, do calculation or whatever. But in the era of Industry 4.0, the paradigm totally changed, right? Now, with with this sophistication, the machines were able to talk to each other instead of human talking to machines. Right now Industry 3.0, the human was supposed to interact with the machine, so the message or whatever the information was fed from human to the machines. But coming back to Industry 4.0, you don't need the human involvement. The machines are able to communicate with each other, right? So this is where we get these fancy words like IoT, which stands for Internet of Things, right? Then we have IIoT, Industrial Internet of Things, where the machines can talk to machines with very less minimal involvement of human, right? So this is where we are, and we are now um, going past Industry 4.0 and even moving to Industry 5.0, which is quantum computing, right? So whole thing of big data, data analytics, artificial intelligence, all this came because of this Industry 4.0. Why? Because when machines started talking to each other, the amount of data generated by the machines they're huge, right? In a given minute, given second, the number of data generated by these machines enormous, right? So then there was this requirement how to analyze data, how to analyze this data, how to come up with meaningful insights, what are we going to do with this data, how we take decisions based on the information. So these issues came up, then only people started thinking about how to analyze data smartly, right? How to do the predictions. So all this came because of this Industry 4.0. The Industry 4.0 took place, the concept took place in Germany, and then it evolved to other countries, right? So the concept happened, the concept rooted in Germany, right? So with that, the there were wearable internet, wearable devices, right? Machine to machine communication, then recommendation system, self decision making system, autonomous problem solving, right? Chatbots, even avatars. So all these things, right? Augmented reality, so all these new concepts, new ideas emerged because of this Industry 4.0, right? So that is the main reason, main pillar, right? So we came to this word called data. So what it means by a data, right? What do you really understand by a data, right? So my left hand side diagram, which is this, right? This one, it shows a categorization of data, how we categorize data. So there are different ways of categorizing this data. I have followed one or two methods, right? One method and sub one is the other one. But if you see another book, you will see a different level of categorization or different type of categorization. But what it says is, end of the day, it's almost the same, right? So when you come to data, we have mainly two types of data. One is primary data, other one is secondary data. So let me explain what is secondary data first, right? So secondary data, you find most of these published books or whatever the articles or whatever. Now, for example, if you take annual reports of companies, right? So that is a source for secondary data, right? So for you, it is a secondary data source because you don't collect that data. You have not collected. It was collected and compiled by someone else, right? So you, if you want to use, you can use that as secondary data source, right? So that type of data where you get data from uh, publication, it can be a printed publication or it can be online publication, whatever. We just simply refer those as secondary data. Then primary data means the data that you collect, right? So how you collect, there are different ways of collecting data, right? So where I will explain that. So even primary data, we have two parts, two types. One is qualitative, other one is quantitative. Now, for example, now let's say if you want to collect the data like height of your class, right? So we have um, about 47 attendees, right? So 47 participants. So let's say if you want to collect the height of all these 47 participants, so this is a quantitative data, right? So you can ask from each of the participant, what is your height, right? So that's how you collect the data, right? You collect the data, uh, giving a question or just simply asking a question, right? So it can be done verbally or as well as you can develop a form and then you can send the form and ask someone to fill the form, right? So this is how we normally collect data, or even you can observe, right? So you can have a camera and you can do some observation and then collect data. For example, number of people entered or went out from the particular home or office or whatever, right? So that's that you can do uh, by physical observation or using a digital observation like camera, right? So those numbers, when you collect height, weight, whatever numbers, so those are quantitative data, right? So there are different types of quantitative data, causal, descriptive, right? Again, we don't have to get into that level, but remember, even secondary data or primary data, you have two types, qualitative and quantitative. And the right-hand side diagram, I have elaborated the data types, right? So data types, as we said, we have quantitative, qualitative. Under quantitative, we have two types of data, continuous and discrete. What do you mean by continuous data and what do you mean by discrete data? Can someone give me an example for continuous data type? Can someone type in your chat example for continuous data type? I'm giving time. Can someone give me an example for continuous data? Good. Height of a group, it can be one person. Why we say height is a continuous data? Why we say height is a continuous data? Because it's a continuous number, right? So we get a height, let's say 5.6 centimeters or meters, right? So this is a continuous number, right? Because 0.6, right? When you have, yes, the other one is weight, right? So if you take weight, let's say 55.5 kilos, again continuous. Why? Because it has this decimal points, right? So this is why we call these as continuous data. Discrete data, maybe number of a number of students in the class, because we can't say 50.5 students, right? There is no sense, right? We don't have a half student, right? So those are discrete there. Number of cars, number of people, right? Number of pens, books, those things, they are discrete because there is no sense if we say 1.5 pens, right? So you have the under quantitative data, you have two categories. One is continuous, other one is discrete. Under qualitative, right? You have ordinal and nominal. So qualitative data is it's not numerical, right? So you try to explain certain thing using qualitative data. Let's say, for example, sex, right? Male, female. That's a qualitative data. Okay. And whether you had COVID, yes or no, that type of answer, right? If you had COVID, yes. If you haven't had COVID, no, right? So those are called qualitative data, right? So under qualitative, we have ordinal where we can order, right? If it is grades A, B, C, D, E, right? We can order. If it is nationality, we can't order. American, we can order, but if there's no sense of ordering, right? So let's say Sri Lankan, British, Slippers. So there is no, we don't see any sense. There is no sense by ordering it. Okay. So again, coming back to data, to summarize, there are two main types of data: qualitative, quantitative. Under quantitative, we have continuous numbers, discrete numbers. Under qualitative, we have ordinal and nominal, right? So mostly we deal with ordinal or categories. For example, in machine learning or in predictive analytics, we deal with different categorical variables, right? Maybe sex, whether the marital status. So all those are categorical variables which are qualitative, right? So that's done. All right. So then we move on to this big data. Why we have this particular word to explain data as big data. So what are the attributes? We qualify data as big data according to these attributes. So some books, they talk about 7 attributes. Some books, they talk about 4, 5, right? But I think if you can understand at least 4 attributes or characteristics, that would be more than enough, right? So when we categorize data as big data, volume matters, right? If the volume is very large, right? If it is in gigabyte, terabytes, then naturally it becomes a big data source, right? For example, stock market data, where it generates data every second, even less than second, because the moment there is a transaction, there will be data underlying whatever the transaction. Data can be the price, it can be the volume, right? And it can be the names for the CDS accounts, right? So there can be number of information. Okay, so if you given a day, the amount of the data generated will be huge. Then the velocity, the how fast, right? The frequency, how fast we get the data incoming, right? For example, if it is a stream data where we get a telecast from somewhere, right? Let's say live match, right? Live cricket match, football match. The number of the frequency of data coming through, so that's called velocity. And then the variety, variety is the formats, different formats of data, right? So some are in Excel sheets, some are in photos, PNG, JPEGs, then video, different types of video files, right? So audio files. So then those are the variety. Then veracity is the trust, how far you can trust the data, right? The trustworthiness, whether you can rely on this data source, right? So these are the 4 V's. Sometimes there can be 5 V's, 7 V's, right? Mainly 3 V's or 4 V's, where we consider um, to categorize data as big data, right? Why we categorize this big data and data, right? Depending on the size of data, the amount, right, and whether if it is a big data, then the technology that we use, techniques that we use to analyze is different, right? Big data technologies are different technologies. Where I am not going to talk on those areas, but remember now, if it is a big data source, if you want to do any machine learning or artificial intelligence related application, there are different tool sets, right? So big data technologies are different. How we how we manage data, how we get data, query data, right? So all these are different uh, when it comes to big data, right? Okay. So then we move on to the next section, which is analytics, right? What it means by analytics. So the word analytics, it represents, mainly this is data analytics. I'm referring to data analytics, right? So it talks about for the it represent, right? How we use computer technology, then management science techniques, and statistics, right? So, what do you mean by management science is it's called optimization. Okay, this the more famous or more familiar term is optimization, right? So, if someone says that he or she is going to do this data analytics, then that means how you use the statistics and optimization to come up with sensible or meaningful insights from a data set using computer technologies, right? So, statistical theory or optimization theory will be implemented using computer algorithms, right? Because as human, we have limitations, right? We can't do all the calculations. So that's why we use computers to do these calculations, right? So whatever the statistics concepts or principles, whatever the optimization principles are implemented using computer algorithms. So this is what we do, right? So this is to solve real world problems. And there are 3 levels of analytics that we talk about, right? There are in some books, there are 4 levels, but basically it's 3 levels. What we want to see from a data set. Let's say we are given a data set um, from whatever source, right? So as an analyst, I would like to check the following. What is happening, right? What has been going on during last week, last 2 weeks, last month, last year, right? So that's called what is happening. Then if we can see what will happen, right? What can happen or what could happen next week, right? And then how to make the best of it, right? So those are the 3 questions that we try to solve, we try to answer as an analyst, right? So let me explain a little bit further. Okay, so I said 3 things that we are going to analyze, or we are going 3 levels of analytics. First one is called descriptive analytics. So descriptive analytics, it talks about what happened, what has taken place, right? Using historical information or historical data, right? Let's say the rain pattern or the rain events that had happened last 3 weeks, right? So daily rain event, the number of millimeters recorded for Colombo, let's say, right? So looking at that, the analyst will be in a good position to tell what happened, right? So this is called descriptive. So you can describe a situation. So how do you describe? Maybe the analyst will be able to tell the average rainfall last 3 weeks, right? Average per day, because the rainfall varies daily. If you have experience last week, we had rain all 5 days, but the amount of rain that we experienced, that varied, right? So one day, let's say Monday, we had maybe 80 millimeters. Then Tuesday, we had maybe 40 millimeters. Wednesday, again, 50 millimeters. Thursday, 20 millimeters. So likewise. So looking at those data, the analyst will be able to tell you, okay, this was the average weekly um, rainfall. Let's say average is 50, right? Then again, he or she, the analyst, will be able to tell you what is the maximum rainfall that took place during that particular week, right? Maximum, say for example, 80. What was the minimum, right? So those are the descriptive analytics measures that we normally encounter, right? High, maximum, minimum, average, standard deviation, right? So mainly descriptive statistics, right? So we can describe the data set, right? How we describe the data set. Normally, when you are given the data set, let's say the weights of the participants, right? Weights of the participants. Then we can say the average weight of the participants, maximum weight of the participants, minimum weight of the participants, median of the participant, mode of the weights of the participant, right? So those will describe the data set. That's what we do by uh, engaging in this descriptive analytics. Can I ask a question? What do you mean by an average? What do you mean by an average? What do you mean by a mean? Mean, no, we call average. Let's say simple average. Can someone explain me? I'm not asking how you do this, right? How you do, I know. Now, let's say we have 3 people. Your weights are, let's say, 50, 60, 70, right? If you ask me to calculate the mean, I know how to do it. 50 plus 60 plus 70 divide by 3. I'm not asking this question. I'm asking, what do you mean by mean? What do you understand by this? What is the meaning? What what do you understand by this? How do you explain the meaning of the average to your grandmother? The way that she can understand. How do you explain the meaning of the average? What it means? Can someone give me an answer? Anyone would like to try? How do you explain the term mean to your grandmother, the way that she understands? Approximate value of one data. That no, no, no. It's not an approximate value because we are going to precisely find the value, right? So if let's say 50, 60, 70, we know exact value, right? It's 50, 120, 180, then mean is 60. We know. Middle level, no. Middle level is the median, right? If I arrange it, so 60 is the median. No. Any other answers? Any number that expressing the central or typical value in the close, but not central. Central is the middle value. No. But what you're like average of the total? Yeah, yeah. I'm asking the meaning of the average, not the average. So you're using the word average. No, I'm asking the meaning of average. Normal value. No, I'm asking you to define the average. What do you mean by average? How do you explain the meaning of average to someone who doesn't know how to do this, who doesn't know what it maybe 2-year-old person or your grandmother who has no idea about this word, the meaning of average of the total, no. Because someone who doesn't know the meaning of the average, then mean value, it's a synonym, right? Mean value is a synonym. Ah, that's good. Sachini. Value that best represent a set of data. Okay. So that's good, right? So we have 50, 60, 70 as our weights, right? So the mean or average is the value that the representative value, right? Value that best represent these three data points, right? That's what we mean by the mean. That's what we understand by the mean. The value that best describe, right? Okay, right. So these are the measures normally that we use to describe, or the way we call descriptive. In descriptive analytics, these are the measures that we use, right? Average, um, then average or mean. There are different types of mean. I'm not going to get into that, right? Average, median, maximum, minimum, range, right? So those are the things that we normally use to explain a data set. Okay. Then we have the next stage, predictive analytics. How we use the historical data set to predict the future, right? Let's say if we know last 3 weeks rainfall, can we predict this week rainfall or next Monday rainfall? Can we do that, right? So this is what we mean by predictive analytics, how we use historical data to predict future events. It can be rainfall, it can be temperature, it can be stock price, it can be anything, right? So can we predict? So this is what we do in predictive analytics. Then there's another one called prescriptive analytics. This is not included in your syllabus, right? So we don't talk about this. But by prescriptive analytics, what we do is we do what if analysis, right? So we can generate several scenarios, right? Let's say if last week rainfall is average is 50, then what will be the rainfall in coming week? If the last week rainfall is 20, what will be the rainfall next week? If the last week rainfall is 75, what will be the rainfall next week? So this is what we call what if analysis, right? Scenarios. Okay. Okay. Right. So we'll move on to next. So this is the same thing. Descriptive analytics. What happened? A preliminary stage of data processing that creates summary of historical data to yield useful information, right? This is done mainly by data visualization. We call data visualization. I will show you how we do this data visualization using some tools, right? Some books have this intermediate thing, diagnostic analytics. What did happen? Why did it happen? So there is diagnose. So let's say we had 50 millimeters of average rainfall for last 3 weeks. Then we further diagnostic how and why it has happened. Why it has happened, right? So that's called diagnostic analysis. It's a part of descriptive. Some books they take it out and make a high level thing as another level of analytics, but it's diagnostic. Why? We try to understand why, right? Then predictive analytics, as I described, identifies future probabilities and trends. There are different tools that we use or techniques that we use. So we'll discuss that later. Prescriptive analytics, again, I have discussed. Right. Okay. So then we move on to descriptive analytics, right? What it means by descriptive analytics. Normally, descriptive analytics, as I said, we use some measures. The measures are mean, standard deviation, range, median, right? And some charts, pie charts, bar charts, scatter plots, right? Line charts, right? So all these things we do to understand the data, how data behaves, right? What it tells us. And using this dashboard, we can try to tell a story. We call storytelling, right? So data visualization and storytelling is a different, a separate area. Okay, so we develop dashboards using Microsoft Excel, Power BI, and word cloud for if it is text data, or it can be even spatial visualizations. I will show what it means, right? And then we can develop these dashboards, and then we can get an idea how the data has behaved, what it tries to tell us, right? And develop a business case or a story, right? Right. So first demonstration. So I'm going to show you. Just give me a second. I'm going to show you a dashboard done using Microsoft Excel, right? Can you see my screen? Can you see an Excel sheet? Yes, thank you. So this is a data set. It has how many data points? 3,203 data points. Yes, 3 data points. So we call this is a row, right? So this is a kind of sheet, data sheet, or you can say database. The simple terms we'll say database. So you have different rows, right? Row. This is a row, right? Row is a data point, right? So you have, so each row, it can carry, let's say, customer data, right? So there is a customer identifier or order identifier or whatever, right? So based on that, we have about as I said, 3,000 odd data points, right? So we have 3,000 odd data points. Okay, so this is mainly a sales data, right? Sale of office furniture, then whatever office supply, right? So now when we have data like this, it's very difficult to understand what it means. Now let's say the sales based on districts. We have no idea. The profitability of whatever the product, we don't have idea, right? Volumes, how many furniture that we have this particular company has sold in Colombo district, or what is the profitability of this firm over the last 2 years. So this is very difficult to understand looking at this data, right? So what we do, we develop a dashboard, right? A set of charts to understand the data in a different way, right? So this is what we call a dashboard, right? This is the dashboard. Now let's say this first one, sales by quarter, right? Each quarter, 2013, 14, 15, we can identify the sales. This is one line chart. Then we have two bar charts, no, rather the pie charts, right? So in this pie chart, we can see profit by different districts, right? Profits by different districts. Let me show you. I am going to increase. See, Matara, the profit is 2%. Vaunia, profit is 2%. So likewise, Colombo, 44. So profit by different districts. Sales by district, right? Percentage sales by Colombo accounts for 40%, right? Candy 28% like this. Then sales and profit by category. Furniture. So under furniture, you have subcategories. Under office supplies, you have subcategories. Under technology, you have subcategories. And each tower gives you different, each tower, the sales. Red towers are sales. Magenta ones are profits, right? For each. Now, if it is, let's say, office supply storage equipment, then the profit is this, the sales is this, underlying profit is this, right? So now we can, it's easy way to understand the whole data set, because this is a visualization. So we have visualized the data set, right? We have visualized the data set. Okay. Now we don't have to go one by one, but we see, right? This is if you want to see the trend, we can just measure the trend, right? So all these things. Now, in addition, the dashboard has some dynamic nature, right? Let's say if I want to find the sales or whatever the information that we have shown here only in the district, let's say Colombo district, right? So I can click the Colombo district. It will give us only Colombo district data, right? Only Colombo district data, right? See, only Colombo. The sales in Colombo, right? So let's say if I want to find only Ampara, see, this is only Ampara, right? Only Ampara. Let's say I want to see only furniture. Now this company has three types of product: furniture, office supplies, technology. Now, let's say I want to see the performance of furniture only. So this is furniture only, right? Furniture only, Colombo, right? This is furniture only, Colombo. right? So using dashboard, we have this, we can have the ability of drilling down, we can drill down, we can do the selection, right? So these are the advantage of having this type of a dashboard. Okay, so let's say if I want to see Colombo technology only, so this is Colombo technology, see, right? So again, all the things and entire country, right? Entire country. So this is what we do using a dashboard, right? I'm not going to tell you how to do it, right? It will take time, but if you want to do, you can just type how to develop a dashboard using Excel. There are plenty of videos in YouTube, right? So you can learn within a couple of hours, you can learn this, right? But you're not supposed to do this. You're not supposed to know how to develop it for your course, right? Not at least for the paper, this paper, right? DLA. You don't have to learn, but what you should know is what is the dashboard, what it can do, right? What it can do, what is the dashboard, right? What type of packages that you can use. Those things you should know. How to do it, you don't have. All right, so this is a dashboard developed using Microsoft Excel, right? So this is a primary level dashboard, right? There are dedicated packages to develop the dashboard. So I'm going to show you next a dedicated package, dashboard developed using dedicated package, right? Right. So this is another dashboard done for a particular company. So they are HR division, right? So they are HR division. This particular dashboard was developed using Power BI, right? Microsoft Power BI. Okay. So this particular department, they do this. They wanted to see recruitment and resignations, right? These two, they wanted to analyze recruitments and resignation, given number of months, right, per year, right? So now these are the two things. And if you want to focus more, let's say recruitment, right? So these are recruitment per month, right? August 56, likewise, right? Department wise. Now let's say manufacturing department, mixing department, napkin, packing, whatever, right? So department wise recruitments. Okay. Um, Number of total employees department wise, right? Um, by month overall, right? So the here gender wise, how many male, how many female, percentage, right? Manpower company, if it is, if this company gets manpower from contract labor, right? Different companies, then you can see that which company has sent how many people, right? Even those we can do, right? So if I want to highlight month of August, then this is only month of August, right? Month of August recruitments that has happened in month of August, right? So if I want the entire country, entire period, it's this. The month of November, it will take time, right? This is month of November because this is hosted in the cloud, right? So this is not in my computer. This is the cloud base. Okay, so this is what we mean by a real dashboard, right? Not Excel, but this Power BI is dedicated package to develop dashboard. There are other products like QLiquid, Tableau, right? There are various products. Power BI is the product under Microsoft. Do you have any questions so far? Any questions? Okay, so selecting this month, and then if you want to select further down and down, we call drill down, right? So we can drill down. Okay, we can drill down month, and then if you want weekly is not here, right? Further levels down, then we call drill down, right? So in a dashboard, we can do this drill downs. All right, right. So I'm going to move to my next. Right. So let's say if you want to visualize text data, the text data is now the data that is there in a paragraph, right? So we call that type of visualization as word clouds, right? So let me share you another um, example. Um, okay, this is TripAdvisor, right? Now in this TripAdvisor, I have searched about the temple of scared tooth relic, that is Dalada Maliga, right? So I have uh, searched the comments given by various visitors about Dalda Maliga. See, different people have given different comments, reviews, right? They have reviews. Now, if I want to analyze these reviews, because these reviews are not in numbers, right? These are text, right? So all these reviews, they are in text. This can be about Dalda Maligawa. This can be about different hotel, the experience of the hotel, whether the hotel service is good or bad, public transport, anything, right? So then you encounter text data. Now, how do you visualize? How do you visualize text data? How do you because you can't do a kind of a dashboard, right? Because there aren't any numbers. But then if you want to visualize text data, then my next example is that, right? So we can use, there are different tools, right? I have used, there's this program called Python, programming language, right? Using this Python, I have tried to develop some kind of visualization about text data, right? So this is the reviews given by various people, right? Number of people they have given. So I have taken 3 reviews and put into one paragraph, right? This is the review, right? So from this review, I'm trying to understand what they have said, right? What they have said. So then if I do the visualization, my word cloud will look like this, right? So how do we read this word cloud? The big, the large font size, right? Now let's say this temple is the largest font size word here. Then tourist, scared, right? Sacred rather, sacred, local. So which means now in this text, right? The number of times this particular word appeared more, the frequency, right? So most people, the reviewers, they have used the word temple more times than any other word. And people, right? Temple, people, religious. So those words were very frequently used. And crowds, right? So most people have said there are there is a large crowd every day. And about the guide, right? Local, day, right? Now, if you take this relic, fast, painting, rainy, so those are mainly maybe used by once or twice, right? By these people. Okay, so this is a way to visualize a text data where you don't have numbers, right? So moment we see this, we know people now. Let's say if I want to run an advertising campaign, so then I would know what type of words that I should use, right, for a particular product or service, right? or even we can further analyze this and we can see what kind of emotions, right? We can categorize these words based on emotion, whether people are happy with this, people are unhappy with this, right? They are scared, right? So use these words can be further categorized and see what type of attitude, what type of feeling that people have or the reviewers have on this particular place, right? So this is called, this is a visualization, but text visualization, right? Okay. Then again, back to my presentation. Right. So I have covered Excel dashboard, Power BI dashboard, and Word Cloud. Right. Do you have any questions? No? Right. So the last visualization, I'm going to show you the spatial visualization. Right. So I hope you can see my screen. So this is Sri Lanka, right? So there are these dots. Now let's say I'm going to take only intake 17. So this is where now I'm coming from university, right? So particular batch. Now intake 17 is 2017 intake of students. So I can visualize where my students are living, right? So this is a visualization to see where they are living. Now if I click here, right? So then I know this Naomi is located here, right? Naomi is here, right? If I click here, I know Kamalani is in Trincomalee, right? So this is a kind of visualization we call spatial visualization to see spatially how they are distributed, right? So my next batch is 2018. I know where they are located, where they are coming to Colombo, where they are coming to Morocco, right? And if I have all three batches, this is my total visualization of our students, where they are located. Why we need this? Let's say if I want to have a bus service, right? So this was done in COVID period. Now, if I were to do this uh, examinations regionally. So I know how many centers that I should put, right? Now, for example, Colombo, Gampa, I can have 2 or 3 centers. But Anuradhapura, people who are in Vaunia all can come to Anuradhapura. You can have only one center, right? So likewise, we can take various decisions based on these spatial visualizations as well, right? So if I want to take a decision based on the location intelligence, this is called location intelligence based decisions, then I have to use spatial visualizations, right? So that's about it. Right. So I have done fair amount of descriptive analytics, right? So then we are moving to the next level, predictive analytics. Do you have any questions for the previous section? No? All right. So now we have moved to the last section, what it means by predictive analytics. So as I said, predictive analytics, the main idea, the primary idea of predictive analytics is whether you can predict the future, right? So for this, the data scientists, most of the data scientists or AI engineers, right? Data analysts, they use machine learning. So what it means by machine learning? So I'm going to give you a naive explanation, a very simple explanation about machine learning. Now, this particular figure, there's this chart or whatever flow chart. This is about conventional programming, right? So conventional programming, conventional computer programming, you have the computer, right? There is a programmer, a person has to be there, and the programmer has to write the program, right? So the programmer has to write the program and upload it to the computer with the data, right? With the data, right? So computer gives an output. This is what we have been doing for last maybe 10, 20 years, right? There is a programmer builds a program. A program can be a set of instructions, right? For example, if it is Excel, I, I input several data set, right? Let's say 1, 2, 3, and then I ask the computer, I instruct the computer to find the total sum, right? So that's an instruction, right? So I input the data, right? And I give the instruction to the computer, and computer does the um, computation, okay, and it gives the output. This is the conventional way of doing or working with computers, right? But with machine learning, this paradigm has changed, right? So what we do in machine learning, we give the input to the computer, right? Let's say 1, 2, 3 numbers, right? And I also give the output. Okay, I say, okay, if it is 1, 2, 3, the sum is 6. I give that to the computer. Okay, then I give a different set of numbers, 4, 5, 6. Then I give the total. It's 9, 15. I feed that also to the computer, right? So I give this, and I say I give 1, 2, 3 numbers, then I feed the output as 6. Then 4, 5, 6, 15, right? So I don't tell the computer to come up with the total. I don't give any instruction. I don't give instruction. I only feed the input and output, right? Then computer is able to compare these two and say, okay, this is total, right? It can generate, it learns, right? Looking at this data, right? Input and output, it learns how this has happened, right? What is the relationship between these 3 data points and this one? What is the relationship between this and this, right? So the computer understands it, right? And in next moment, let's say next moment, if I give 10, 11, 12 as my data set, right? Then computer will know, and I'm not going to give the total this time, because now I have made the computer to learn, right? With these 2 data sets, right? With these 2 data sets, I made the computer to learn. Now the computer is able to tell, okay, so the answer is 21, 33. So this is what we do in this machine learning, right? We make the computer fellow intelligent. We make him to learn using the data. We don't give this instruction. Program, that we don't give. The set of instruction we don't give. Instead of giving the instruction, we give the input and output and ask the computer to learn, right? This is the whole idea about this machine learning, right? So there are different terminologies. The bigger sphere is AI, right? So because there are intermittently they use different words. Artificial intelligence is the big sphere, right? So there is even bigger one. Computer science. Computer science is the bigger one. Then artificial intelligence, then data science, machine learning, deep learning, there are various other things. Meta learning, reinforcement learning, there are so many things have come up, but the bigger sphere is computer science, then under that the sub sphere is AI, right? So machine learning is a subfield of artificial intelligence that gives computers the ability to learn without explicitly being programmed. So we are not going to program anymore the computers. We let the computers learn by looking at the input and output. And then when we submit or upload the next set of data, the computer should be able to come up with the output. Because previously it had learned from historical data, right? So we have submitted historical data, historical inputs. For example, let's say if it is about stock market data, right? So let's say with the days, we have input the values, right? Closing prices, right? So then looking at that, the computer will be able to predict next week prices. If that it's something like that, right? So there are different types of machine learning. Okay, so this is just for your information. You don't need to really go through all this, right? So the main branches, one is supervised learning, other one is unsupervised learning. Then the third branch is reinforcement learning, right? So we are only focusing on supervised learning, right? Even we don't need to know unsupervised learning, right? Only our focus is supervised learning. Right. So what do you mean by supervised learning? Let me explain with this. Right. It's a type of machine learning where raw input data is corresponding to results are known. That's very simple thing. I will explain you. What I have explained is more than enough. Let's say we have input. We call input data or input feature, right? Or input variable, independent variable, whatever, right? So it's the same thing. So we have a function where it's x, we input x 0, 1, 2, 3, 4, right? Okay, we input 0, 1, 2, right? Whatever number. Then if the y variable, what we want to predict is known, then that's called supervised learning. If this is not known, then it's not the supervised, because if it is known, we can supervise the computer. We can tell the computer, see, look, these are the outputs. These are the values. You have to learn according to this, right? That's what we call by supervised, right? So for 0, there is a corresponding value. See, 3. We tell the computer. For 1, there is this corresponding value 8, right? 2, there is a corresponding value 30, right? For each, there is a corresponding value. So we can guide the computer. This is called a label. This is a feature, right? For each feature, there is a label. We can guide the computer. Okay, 0, this is the output. For 1, this is the output. 2, so this is what we call supervised machine learning, because we can supervise. We can tell the computer, okay, for each x variable, there is a y variable. But there are some data sets where we have only x variable, no y. Y is not there. So those where we call unsupervised. We can't supervise the computer with that, right? Only x, then the computer has to find some relationship pattern or whatever, only looking at x. There is no one. But here we can supervise the person. We can supervise the fellow, right? So we supervise the fellow up to whatever numbers, 3, 4, 5, right? Then we have some numbers for this, right? So we train the computer, okay, if it is 0, then 3. If it is 1, then 8. Then ask the computer, right, to find this relationship, how this happens. What is the equation? Y equals what? So then computer finds the pattern y equals 5x plus 3. Looking at this data, it finds this relationship, right? Now, conventionally, we used to give this, but now looking at data, computer is able to find the relationship, right? So then what we do, we tell the computer, okay, if it is 6, what is the value? Now the computer knows the relationship, so it can find the value, 33, right? So this is what we mean by supervised learning, right? For number of data points, we supervise the computer and we make it learn. We make it learn. Learn means to find these parameters, slope and immensely. Learning means it finds this relationship, how 0 becomes 3, how 1 becomes 8. This will be able to learn, right? Maybe 1 or 2 points it can't learn. Now let's say if I give only 0 and 1, the computer may not be able to learn. So that's why we need large data set. We need maybe 100, 200 data set to learn, right? So with that, with reasonable accuracy, we call reasonable accuracy, the computer will be able to estimate these numbers, 5 and 2. Sometimes it might find 4.9 as the number, right? Not 5 exactly, right? To reasonable accuracy, it will be able to determine these numbers, the parameters. Then moment I give 7, 8, it can estimate whether it's 32 point whatever it can predict. So this is what we mean by supervised learning. Do you have any questions? Any questions? No? Hope this is okay, right? Right. So this I have shown how we do it. Okay. So this is the high level diagram how we do this machine learning. So let's say we have 1,000 data points, right? So we have 1,000 data points. Now, early example, we had 3,200 data points. Now, let's say we have 1,000 rows, right? In our Excel, we have 1,000 rows. Okay. So which means we have number of independent variables and let's say x1 and x2. These are the independent variables. Y is our dependent variable. Y means, let's say, we want to predict the rainfall. Y is rainfall. Rainfall, right? Rainfall. We want to predict the rainfall, right? So X can be temperature and X2 can be humidity. Humidity, right? So two variables. So now we have 1,000 data points. Let's say last 2 weeks or last 3 weeks, we have maybe minute-wise data, not hourly, right? So let's say we had 30 days, 30 days into 24 hours, right? 30 days, 24 hours means 720 data points, hourly data, right? So we'll say 720 data points. Okay, we have 720 data points. Now we are going to learn, right? We are going to make this computer learn with these data points. We are going to feed hourly temperature, hourly humidity, and hourly rainfall. right? So this is what we do. So these x1, x2, rainfall, the temperature and humidity, they are called either input variable, independent variable, or feature. In data science, we call these features, right? So why is the dependent variable? You know this, right? For A levels you have done. Why is the dependent variable? But in our terminology, data science terminology, under supervised learning, we call labels, right? So sometimes it called target variable as well. Okay, so what we do, we first identify what are the features and what are the labels, right? That we need to understand, right? So otherwise we can't do this. Okay, first we have to understand the label and features. We call feature engineering. So this part is called feature engineering. Then we divide this 720 into two split. We call splitting, right? Split 720 into two data sets, two groups, right? 80% and 20%, right? 20% and 80%. 20% of um, uh, 720 is 144. The rest is, what is the number? It is 6. Okay, about 676. So we split it into two groups. One group has 676 data points, other group has 144. So we use training data 676 as training data, other one as 144, right? So training data means we are going to train our model, right? So this model y2 we don't know, so y whatever equals if x1 x2, right? We don't know what it means. We don't know the relationship. We don't know the relationship, right? So we feed the machine. Okay, first our temperature is this, humidity is this, rainfall is this, right? So we feed this. We feed the data: temperature, humidity, rainfall. First hour, let's say um, the temperature is 29 degrees, humidity is 80%, right? Rainfall in terms of millimeters, 10 millimeters, right? So likewise, we input all these 676 data points, right? Data points, all these. And ask the computer, okay, why not you learn the relationship? You learn the relationship between y and these two x's, right? We ask it to learn. Okay, so there are different algorithms. It can be line, we can pick line, or it can be different tree diagrams. So there are different machine learning algorithms. So I'm not going to talk about those things, right? So we make it learn, and we can check the accuracy of learning accuracy, how far this learn, right? Then we have the other set of data, right? Where we have separate out 144 now, and we feed this 144 to our model and see whether we predict properly, right? Whether we can predict properly, because we know for this test data, we know x's and y we know, but using this one, we know how to predict, right? For this 144, we know the predicted and actual, right? We can predict from the algorithm, our equation we can predict, and anyway we know the actual, right? We know the actual. Then we can compare for the predicted whether we are close to the actual. The predicted, are we far away from the actual, right? So using test data, we can evaluate the model, whether the model is performing well. right? If it is yes, then we can predict next week. Whatever the data, we can predict the temperatures, given the temperatures, given the humidity, we will be able to predict the rainfall, right? So we know, okay, next hour, if the temperature is this and humidity is that, we know, okay, there is a chance for 10 millimeters of rain, 20 millimeters of rain. This is what we do, right? So the whole thing of machine learning, the machine learning concept is this, right? But when we do it, there are some sophistications that we have to do. But what we do is this, irrespective of whatever algorithm, this is what we do, right? Basic structure of the process, right? The process of doing machine learning is this, right? So I'm going to discuss little more about this linear regression, one of the machine learning algorithms, right? There are different types of machine learning algorithm, linear regression, because you know, right? You know what is linear regression. It's a fit a line to this data, right? So you have done since you have done in your O levels. So I'm going to do this, but others like classification, the decision trees, I'm not going to do because you have no idea about those in your O level study, right? So let's say we have this data set, right? Um, the red ones are training data, black ones are test data, right? So since let's say we have split the data set into two, right? So now if we were to fit a line or fit any curve or line, we can do like this, right? We are fitting to the, sorry, now we have to fit to the test data, right? So we will change this, right? So this is test, this is training, right? Training. So we are going to fit initially for the training. Okay, black ones are training. So we can say fit to this. If we were to fit a line, this is how we can fit. How do we fit a line to this? What is the strategy to fit this line? Based on the distance, right? We find the overall distance, total distance of each dot, right? So this distance, so there are the distance are this, right? So these are the distances. This is the distance, right? Okay. So let's say this D1, D2, D3, D4, D5, D6, D7, right? So the total of all these Ds, D1, D2 plus D7, the total distance, we fit the line such a way that this distance is almost the lowest, right? The lowest distance, right? Where the distance is the lowest. To be frank, this is we take the square of the distance, but roughly we will say the distance, right? So where the distance, the total distance get the lowest, right? Because we can fit different lines. We can fit this line, we can fit this line, right? So there are a number of lines that we can fit. But the line that gives the lowest distance is called the best fit line, right? So this is for the test data. Once we fit this line, then we can find the equation for this line, right? For example, 5x plus 3. This is what we do, right? We fit the line and then we estimate the equation for this, right? This is what we mean by training, right? Apart from fitting a line, we can fit a curve as well, right? If we fit a curve, you can see the curve process all the dots, right? The line, it misses certain dots, but curve, it almost touches all the dots. It almost touches all the dots. Okay. So now which one is good? Which one is good? Line or squiggly line? We call curve is squiggly line. Which one is good? If you want to fit. Which gives us the best fit? Line or squiggly line? Apparently this is good. Apparently this is good. But the issue is, so see, right? Apparently this is good. But the issue is what? Moment we put the test data, the scenario is different, right? For the training data, yes. But the test data, the squiggly line or the curve, it misses the dots by a lot, right? See, because other now we have two sets of data now. We have we from the bigger set we split the data into two, training and testing, right? So of course training, if we fit the line, if line misses certain dots, but this crooked line, right, squiggly line, it doesn't miss the dots, right? It hardly misses any dot. But moment we put the test data into it, then there is a problem, right? So this is why we say, now given a set of data, in most cases, line is performing better than these curves, right? The curves may not perform better. The regression line performs better because the variance, right? The bias and the variance, we call bias and the variance. Looking at the bias and the variance, the line performs better, right? Okay, so this is the underlying theory, right? Using this the concept of whatever the lines, right? So this is why we go for the line, but not a curve. Otherwise, one might argue, okay, why not a curve, right? Why not this type of a curve? Because that type of a curve won't fit with the test date, right? So the variance is very high. Here the variance is very high. That's right. One simple application of some other algorithm which calls classification. If you want to classify into two, now this is regression. We want to fit the line and predict future, right? We are going to fit line to the x variables, right? Let's say temperature and humidity, and then we can whether we can predict the rainfall. But let's say we have a different application, like to classify, group certain things. So how we do? For example, email. Now we get an email. So I need to know whether my email is a spam or not spam, right? So it's a classification problem. Classification problem. I need to classify whether it is a good or bad, right? Now let's say some items, some product in a production flow, there are certain items coming in the conveyor. So I have to decide good ones, bad ones in terms of the quality. So those types of problems are called classification, right? This type of problems are called the regression type of problems where we need to predict the future. Here we are going to predict whether particular email or whatever is falling into good category or bad category or spam or not spam. So we need to make sure that next email coming to me, can I safely categorize this as spam or not spam. So this is called classification problem, right? So again, what we do, right? So we train the algorithm using training data. So here the training data is we use different. Now, if the male doesn't have a name on it, dear, dear friend, my dear friend, that type of, where the male doesn't carry any specific name, right? It doesn't address a person, right? It generally addresses. Or it has words like lottery won, you have won a lottery, right? So that type of words, if it carries that type of words, we can train the model, okay, if this particular male has these words, consider that as a spam mail, right? So based on the words, text, we train this, whatever the classification algorithm. Once we train it, then whatever the test data, we can check whether the algorithm is working or not, whether it's working properly, accurately or not. Once this is established, right, we can safely say next mail coming to your inbox is safe because it is not going to the spam box because our model works well. This type of problems are called classification problems. We have to classify whether particular whatever it can be email, it can be product or anything, right? If you want to put it into one of the groups, it can be more than one, right? More than two, three, four, whatever categories, then that's called classification type of problems, right? So both are examples, classification and regression types of problems are examples for machine learning. Under machine learning, we can use machine learning algorithms to solve this regression type of problems and classification type of problems, right? So you need to know, given the problem, what type of problem is that, what type of algorithm that safely we can use, right? For example, if it is prediction of uh, price, quantity, rainfall, that type of thing, right? If you want to predict a specific value, then we use a regression line, right? If you want to separate, categorize certain things into a group or categories, right? Maybe age categories, right? Maybe weight categories, or maybe um, good, bad, right? So those are classification type of problems. So we can use classification algorithms, right? So as the last thing, some machine learning applications that we use in finance world. So the most famous ones are loan default prediction, right? So let's say a bank or any financial institute, they would like to know whether the person who is applying for a loan, he is going to be a defaulter or not, right? Or even it can be a current customer, right? Customer who has enjoying right now a loan facility, whether that person is going to default maybe next month, right? So this type of problems are there. This type of insights are needed by these financial institutions. So those are called loan default prediction, right? So what they do normally, they assign a risk variable, risk tag to each customer, right? So depending your age, your marital status, whether you have a house, whether you have a car, whether you have a continuous salary, right? So depending on various features, various independent variables, you can assign a risk level, right? Maybe out of 100, you give if the person is married, if he has a house, if he has a executive level job, then he might have less risk. Maybe out of 100, risky level maybe 10 or below, right? Let's say there is a person who is single and he's in an entry job type of thing, right? Just started the job. then the risk level may be high, right? And the way that person has now, if it is a current customer, whether the current customer has obliged to the periodic payments properly, or has he been late, right? Are there any delays in his previous payments? So based on those information, we can train a model to see whether particular customer is going to default the payment, right? Default the loan, right? And then categorize non-performing customers, NPAs, right? So this loan default prediction is major application that uses machine learning algorithms. Then the other one is portfolio optimization, right? So asset portfolio. Now let's say if I'm going to buy shares from in this share market, right? So to have the maximum return, to enjoy maximum return and minimum risk, right? So what is the optimal weights of or different types of assets that I should carry in my portfolio, right? For example, if it is in Sri Lanka, how do I have to have now? Let's say I have 100 shares. How many shares that I should have from John Pierce? How many shares that I should have from Haley's? How many shares that I should have from let's say carvings, right? So this weights the weight, right? Optimal weight that gives you the maximum return and the lowest risk, right? So the portfolio optimization models, now these days we use machine learning to develop, right? Then credit risk management in banks, right? Then there's another thing called algorithmic trading, high speed trading platforms, right? So now we have conventional, instead of conventional stock markets, we have this high speed trading happens in real time, right? Real time stock markets where if we have access to that type of algorithms, then we can go for this algorithmic trading, right? So those are some examples for machine learning applications in finance world. Apart from that, we have different large number of automations, right? Chatbots, surveillance agents, right? Surveillance chatbots, okay? All done by machine learning based applications, right? So these are some examples that we can talk about in the area of AI applications for finance, right? So with this, I have come to my the conclusion of today's session. I can give you maybe whatever amount of time, right? If you have questions, I'm happy to answer. So in terms of your paper, like last time, for previous years, it will be MCQs, right? So we have no intention to go to structured or whatever. So it will be like last time or previous years, it will be MCQs. Any questions? No? Right. So if you have any question, you can send it directly to the institute and they will direct it to me. So I'm happy to answer. If you have any issue, anything that you don't understand in the text, so whatever, right? So we'll meet next week as well. I will explain the first chapter, the concepts that are there in the first chapter. So next week. Gusta, we are okay, I think. Hello, Gusta, we are okay, I think.
Doctor?
Yeah, I think we are okay now. We can conclude the session for the day. We'll start next week of the other one.
Yeah, sorry, there was a technical error from my end. Thank you so much for your contribution, Doctor, and for the students. I must say thank you for the students especially. And we are meeting on next Friday at the same time. Please share the information, the news of this session with your friends also, my dear students. So we will meet up again on next Friday. Till then, goodbye. Thank you so much, Doctor.
Bye. Bye.